Okay, I'm Guoqi again. So here is my colleague Tenda, and he is the developer for the protocol test framework. And if you are running the test suite, you see the protocol test manager, the cool UI, to run the test suite, and also developed by Tenda. So today I will cover the protocol test framework, cover a little more. On Monday, I had around about 3 slides, just a high level of a PTF. So today I will get a little more about the PTF. And this is the agenda. So basically cover about what is the protocol test framework and our design goals, and the high level functional architecture, some key features, and then Tenda will give everyone a demo of how to use the PTF. So the PTF is a framework developed based on the Visual Studio unit test framework. All the test suite, like file sharing test suite, AD test suite, and the MOD test suite, the Office test suite, they developed the test suite based on the protocol test framework, and it was released in March to the MS Connect, and you can search it from the MS Connect, and we released a beta version. It's a 1.0 22.20.0, and it has a short description about the version. So we released on March 20th. And here is kind of high-level design goals. So we want to provide a common infrastructure and a library for test suite developers to develop the test suite for both Windows and also Office. So we want to simplify the development. And we also want to make sure that it can work for both the traditional testing and also the model-based testing. Some of our test suite are developed based on the model-based testing. And we have some dedicated support for multiple test adapter implementation, and we also have the multiple logging support. For the adapters, like on Monday, I briefly talked about we have 3 major adapters: the PowerShell, the interactive, and the managed adapters. For logging, we have file logging, console logging, and ETW logging, and also you can create your own logging. So these are the major design goals. So this is a high level of the functional architecture. So in the central part, the PTF runtime. So we have 3 big components. One is adapter. So just as I mentioned, we have the managed adapter, we have the PowerShell adapter, and we have the interactive adapter. So interactive adapter is a UI, and the managed adapter is you can implement with the C# code, and the PowerShell adapter is user to map the method in the manager code to the actual PowerShell script. So for the checkers, for the assert, we use it to verify whether the test result match the expected result. And for the debugger, we use it to log some internal test code. Then for the logging part, we have the console logging and the file logging and the ETW logging. For the ETW logging, when you enable the ETW logging, we can use some capture tool like the MMA to capture the network messages and also the test log messages. So the logging and adapters, those can be configured by the PTF configure file. So those are the XML files. And for the adapter and adapters, we need to implement it either use a PowerShell or Magic code. So this talk about how the PTF works. So initially, when we develop our test suite, we have a synthetic client, and we test the synthetic client against the Windows server. So we use a PowerShell to control the SUT, and for example, we say, okay, well, I have the SUT IP address and I have the username, and to make sure, okay, the client is able to talk to the server, and we verify the message sequences. So when we test our synthetic client with the partner server, then the PowerShell script doesn't work, and the username of the administrator of the Windows will not work for the partner server. So we need to find another way to make the client to talk to the server. So we introduce the configure file. So we move like the IP address, the username to the PTF config, and then we also change the adapter from the PowerShell to the interactive, so you can manually configure the SUT, and then after you configure the SUT, you continue to run the automations. Then how do we verify the synthetic client works with the partner server correctly, like all the message sequences are right? So we have everything logged. We have the test rate log. We can also capture the network messages. Then our test rate will verify the message is right. So any questions so far? Next, I will talk about several key features. The first key feature is the configuration. We have the PTF configure and also the deployment configure. The PTF configure to define the adapter type and the login type. The deployment configure defines like the test environment, such as the IP address, the username, the password, the OS version, the protocol versions. And the right side is just a simple example. We copied from the PTF, the deployment configure files. This is about adapter. So adapter is used to control the SUT state and also trigger the network messages. And those can be configured manually, configured at the runtime. And there are three major adapters: the PowerShell adapt, manager adapt, and also the interactive adapter. I will talk more about these adapters. So how adapter works? For example, I have some code, and I defined a method called a method in a test case, and the test case is using the sum adapter. Sum adapter is adapter name. So a method takes two parameters. When I use the PowerShell adapter, so I have the PowerShell adapter. It will match the method name to the PowerShell script name. So we have a method in the C# code. Then I will have a method.ps1 in the PowerShell script directory, and it takes two parameters. So for this one, it's a very simple one. We just want to check the second parameters is equal to 2 or not. If it's equal to 2, then it will return 0. If it's 1, it return 1. Not equal to, it return 1. And then when the PowerShell adapter is called, it will run the method.ps1 and return the result. So when we change to the interactive adapter, when any method is called, a dialog will pop up, and it would have the method name. So displayed. This is like the method name is a method, and then it will have some help message, and it expect to have the action parameter is the input parameter, and then the action result is the expected result. So you can play with the action result, and then you can either continue or abort. So this is more about the PowerShell adapt. So we use the type is called PowerShell, and we have the name is, for example, we call the name is IRDP SUT control adapt, and the script there is the directories which contain the PowerShell script. It can be just a relative path or an absolute path. So in this example, we have the adapter is called the IRDP SUT control adapter. So in this adapter, we have several methods. Like if we look at from the end, it have trigger input events like trigger client disconnection. Or for this method, we have the related PowerShell script called the trigger input events and trigger client disconnect. Also, the name must match. The benefit of using the PowerShell is you can just pass the parameters directly, and there is no passing issues when the parameter is passed into the code. For the interactive adapter, we will just say type is interactive. Then we use a name the name is the interface name, and it is used to control the SUT manually when the other automatic control method is not supported. So when a method is called, a pop-up dialog, a UI will pop up, and it has some, like for example, in these cases, the method is called like run cleanup, and it has some helper message says like enter 0 for successful return or non-zero error code. Then you can type 0 or non-zero in the actual result, and then you can click continue or click abort to continue the test suite execution. The third adapt is a managed adapt. So in this case, the type is managed, and we have the name is the interface name, and the adapter type is the class name which contains the adapter. So in this case, our class name is like RDP, the RDP EI SUT control adapter. It's a protocol. It's a RDP UI RDP EI protocol. So in this class name, we have the IRDP EI SUT control adapter. That is the adapter name, and then we can implement all of the method in the C# code. So that are the three adapters. So the next feature is about logging. So the PTF provides several logging styles, like the file sharing, console, and the ETW logging, and also the custom logging. So for the file logging, it just logs the messages to the file, and with two formats. It can be the plain text format or the XML format. For the console logging, is you can see the execution progress when the test is running. For the ETW logging, you can log the test suite log and also test messages as the ETW provider. Then you can use the capture tool like the Microsoft Message Analyzer to capture the network messages and also the test messages. For the custom log, you can create your own log by inherit the abstract class. We have the abstract class called Microsoft.protocols.test_tools.login.logsync. So you can create your own custom logs. When you install, say, if you go to the online to install the PTF, you will have also download a user guide. So the PTF user guide will have the details about how to create your own custom log. So this one is like the super logging with MMA. I covered this on Monday. Basically, like originally when we want to investigate some test case failures, we need to look at the different different test logs from using different tools like the test case log, the network traffic, and the encrypted messages. So we need to look at the test messages from using different tools. With the ETW log, we can use MMA, just one tool to view everything. We can use MMA to view the test log. We can use MMA to view the network traffic message, and also to see the messages before the encrypt, also the messages after decrypt. So this can make the test suite develop or debugging easy. This one, I think everyone see this on Monday's session. It just shows an example of how to see the test log to the network log or the encrypted messages from the MMA. Like the brown color is our test log messages. The black one is the network messages, and the green one is the messages before the encrypt. And also like the last this part is the messages. For the last item, it's the messages after decrypt. So MMA we can use MMA to see the different test messages, and Tenda will give us a demo to show like how before the test we can open the MMA and start trace. Then after we finish the test, then we can use MMA to view the different test messages, and also the network messages. So for this PTF, we have a new feature we called like a network capturing. It's only available on the Windows 8.1 or the Server 2012 R2. So it provides a way to capture the network traffic automatically, and you can configure this in the PTF configure file. And like group name, we call it network capture. We have 3 property enabled: capture file folder and stop running on error. So to automatically enable the network capture, we can set the value is true, and capture file folder is the location you store the capture, and stop running on error. We set true is the test will stop running. If it's true, then if it's false, it will ignore the error and continue running the test. And this message is saved as ETL files. Okay, so any questions? This is all about the PTF. If no question, then Tenda will give us a demo on how to use the PTF.
Hello, I'm Tenda, and I would like to give you a demo on how to use PTF to test a very simple scenario. That is, in the initialize, we start a server, and then our test suite send. Sorry. Oh. Okay, and in the test case, our test suite send a request to the server, and the server returns a response, and we verify the response, and in the cleanup, we shut down the server. Okay. What's wrong? Okay. Here is our test suite. We use an SUT control adapter to start and stop the server. So, and these 3 references are PTF references. And in the test settings, in the deployments, we deploy the start server and stop server.ps1 files and the PTF config files to the current folder when our test suite is running. Okay. here are the here are the server we are going to run against. First, we will run against a Windows server, and we will use the PowerShell adapter to start and stop the service. And then we will run against a Linux server, and here I will show you how to use interactive adapter. Okay, first in the ptf config file, first I will change the adapter to PowerShell adapter. And the IP address for the Windows server is this 20. So before I run the test case, I would like to start the message analyzer to capture the test log and the network messages. So we start a new session and use local link layer to capture the message on the wire. We'll only need to capture the message between the driver and the SUT, so we only choose one adapter. And then we add a provider called protocol test suite. Okay, we use this adapter, this provider to capture the test suite logs. Okay, we start the capture. And then we run the test case. Okay, in the message analyzer, we can see some message from the module called the protocol test suite. These messages are the test suite logs, and the other message are the message on the wire. So we can see here, connect to server. So these messages are the three-way handshake, and the send calculate request 1+1, and here we can find that our test suite send 1+1 to the server, and the server returns a 2. And now we verify if the server the return value is correct. So here we can see that the check is succeeded, and the test passed. Okay, we stop the capture. We can see that this test case passed. The server returned the correct value, and now we will run against the Linux server, and the IP address is this one, and we cannot use PowerShell to control the Linux server automatically, so we change to interactive adapter. Here is the Linux VM. Okay, we run a test case. Okay, the test suite pop up the dialog and saying, please start the calculation service. So I start the service on the machine manually, and then press continue. Okay. And then a dialog popped up, please stop the calculation service. So I stop it. and then press continue. Okay. The test case passed. So, and we can also see the log here, and the test suite sent a request 1+1. Also, server returned a correct value. So, okay, that's the end of the demo. Thank you. Any questions? Okay.
Thank you, Sandra, for the demo. And Kevin, you already installed the PTF for your own development work. Kevin, from Oracle, you said you already downloaded the PTF and do your own development work, right?
It occurred to me after we spoke that I was probably using the wrong terminology, that I used the protocol test library extensively for sending out the protocol elements. I haven't really encapsulated the protocol test framework into the test tool.
Mm-hmm. Okay.
Okay.
Okay, thanks. So, any other questions? Okay, so if no question, then okay, this session is done, and you can catch up with us in the conference room if you have more other questions. Thank you.